Open-source models finally seems to be winning the battle against OpenAI's ChatGPT. Microsoft, in collaboration with the universities of Wisconsin-Madison and Columbia, has introduced the latest version of the LLaVa model, LLaVa-1.5. LLaVa is one of the first truly performant large multimodal models, LMMs, and it has undergone significant upgrades. The results are highly impressive, especially considering that LLaVa 1.5 is hundreds of times smaller than models such as GPT-4 Vision, which is OpenAI's latest release that has been taking the world by storm. What does multimodality truly means? Multimodality refers to a model's ability to process at least two different modalities being various types of input data such as words, images, sounds, and more. However, this definition can be deceptive. For instance, if we combine a speech-to-text model with an LLM, we can create a solution that processes both speech and text. But does that make our solution truly multimodal? Yes, technically the solution does, but the models being used in this solution are not truly multimodal. To achieve true multimodality, a model's different modality components must share a common embedding space. In simpler terms, let's consider a visual and text model like LLaVa. Multimodality occurs when the visual and text components encode the input into the same high-dimensional vector space. This vector space, known as the embedding space, transforms all input, text, images, spectrograms, etc., into dense vectors that incorporate key semantic information about the underlying data. In this space, similar concepts have similar vectors, allowing the model to understand that the closer two vectors are, the more similar the data they represent is. This understanding of relatedness forms the basis for how machines comprehend our world. It's all about the connections, as OpenAI describes it. For example, if an image of the Taj Mahal and its Wikipedia text description have highly similar vectors in this embedding space, true multimodality has been achieved. The model recognizes that the salient objects, in this case, the Taj Mahal, from both modalities represent the same entity, just as a human would. Now, how did the researchers manage to achieve this with LLaVa 1.5? They employed a method called grafting, which proved to be both cost-effective and elegant. Now, how did the researchers manage to achieve this with LLaVa 1.5? They employed a method called grafting, which proved to be both cost-effective and elegant. There are three main approaches to achieving multimodality. The first is tool/model-based methods, where different models or tools are combined to handle multiple inputs in a solution. However, although the solution may be multimodal, the underlying models themselves are not multimodal. Another option is grafting, which involves using pre-trained image encoders and LLMs, and projecting the encoder's vector embedding into the LLM's latent space using a projecting matrix or an MLP layer. Lastly, there are generalist systems, which likely encompasses how GPT-4V was trained. With this approach, an image encoder and an LLM are trained from scratch, ensuring that all weights are trained from the ground up. The results obtained from LLaVa 1.5, especially the 13B model, are impressive. Out of the 12 most popular multimodal benchmarks, LLaVa 1.5 is the new state-of-the-art, SOTA, for 11 out of the 12, beating other popular open-source models by a landslide.